In this problem, we're going to be doing a distance equals rate times time problem where we're going to be finding the average paddling rate. The question reads, Sarah wants to know her average paddling rate on a canoe trip to a campground. On the way there, it took her 8 hours against the river's current. So I'm going to underline that. All right, and the current is 2 kilometers per hour. On the way back, right, the same distance took her 3 hours. What is Sarah's average paddling rate? So first of all, when we're thinking about setting up this type of problem, setting it up in a chart like this in a little table might be really helpful. So I have the distance, rate, and time along the top, and then down the left-hand side I have against the current and with the current, because those are the two things that we're given information about. So when we're talking about the distance, right, we know that this is a trip there and back, right, and it tells us here, right, that it is the same distance, right? If it's a round trip, we're talking about the same distance. So I don't know what that distance is. It doesn't give it to us here, but I know it's the same. So I'm just going to put D in for both of those distances because we know they have to be the same. And then when I move over here to rate, the rate is comprised of two different things. So let's break this down a little bit here, right? Because we know that how fast she's paddling, right? So the paddling rate plus or minus the rate of the current. Right? If she's going with the current, she's going to actually be going faster than what she can paddle. And if she's going against the current, it's slowing her down. So we need to keep that in mind when we're talking about rate, what we're going to be filling in here for rate. And then let's just call R, right, the rate that we're trying to find here, right? So I'm going to call that R. And so if she's going against the current, then whatever her rate is, it's going to be minus 2, right? Because it's 2 kilometers per hour. We don't know what her rate is, but we know she's being slowed down by 2 kilometers per hour, right? And same thing on the current, we don't know her rate, but again this time it's with the current, so instead of being minus 2 it'll be plus 2, right? And then the times are given to us here also, so we're given 8 hours is against the current and 3 hours is with the current, which makes sense. It should go faster if you're going with the current. So now we need to set up these two different equations. So let's do that. So I have my top equation is going to say distance equals rate times time. I'm going to just kind of switch these so I have the time times the rate, just because I like it better that way, but it doesn't matter because with multiplication you can do those in either order. And so 3 times R plus 2. Right? And so then I know that I can kind of use the substitution method here to solve this, right? I can put all of this, because this is what D is, right? I know D equals all of this, so I can put all of that in place of D in that top equation. And when I do that, I get this. So 3 times R plus 2 equals 8 times R minus 2. Then I'm going to distribute through here, all right? And then that will give me 3R plus 6 equals 8R minus 16. Let's get our R's on the same side of the equation and move our numbers to the other side. So see here, when we do that, then we're left with 5R on the left side equals 22. Sorry, negative 22. negative 5r equals negative 22. And then I'm going to get r by itself by dividing by negative 5. So r equals, if I put that into the calculator, it's going to be 4.4 kilometers per hour. Okay. And so that is the rate in which Sarah is paddling, and that is what we were looking for. So that will be our answer there. So we can say, write it down in words underneath it here. So Sarah's paddling rate is 4.4 kilometers per hour.